Okay, so today we're going to factor trinomials. That's how many terms? Three terms. Okay? We're going to factor trinomials. Every single factoring method, you always want to check for a greatest common factor first. If it has a greatest common factor, you need to factor that out first before you do grouping or any other method. Take out your greatest common factor first. Now, trinomials, if it can be factored nicely, if you have a trinomial, when you factor it, it will equal to binomial. Binomial times a binomial, right? Like when you did the AC method or T-chart, it equals a binomial times binomial. Okay? What we're going to do is first you're going to write the parentheses times parentheses. Then you're going to look at your first term. For example, you're going to look at this a squared term. And you're going to take that and you're going to guess the factors that multiply to equal that first term. So that's a squared. Our only options are a times a. Okay? But if it was 4a squared, then you could do 2a times 2a, or you could do 4a times 1. So, in your answer, this would be your answer. When you multiply your first terms together, they should equal your first term in your trinomial. Okay? So you're going to guess what those factors are and put them in your answer. And then you're going to take your last term. And you're going to guess those factors, because when you multiply your last term times your last term, it has to equal your last term in your trinomial. So that's the guess part. So you guess what the factors are. Then you check to see if you guessed correctly. And the way you check, you know that it's right if you multiply in your answer, if you multiply the inside terms and the outside terms and combine them, they have to equal your middle term in your trinomial. If they do, then you did it right. And that's your answer and you're done. Now, it doesn't matter. Now, when we taught the AC method, remember there was a short method and a long method. Like if there was something in front of your squared term, then if you did the AC method, it was kind of long. You had to do grouping and all this, right? It was kind of a long process. This can, in most cases, shorten that process. Because it's just about, now you definitely want to use pencil. You don't want to use pen, because you're going to be guessing these factors, and if they're not right, you're going to erase, maybe switch the factors around, check it, then it might be right. Sometimes it's right, the number's right, but the sign is wrong, so you may have to switch those signs. Okay? All right, so let's look at this one. So the instructions just say a factor. It doesn't say solve. There's no equal sign there. So all we're going to do is we're going to take that trinomial and we're going to break it up into its two factors. So what we're going to do is we're going to take our first term. X squared. I only have one option for that. Is what times what? X times x. Okay, so I don't have another option for that. So that's going to be in the right place. Now, 15. What are my options? 15 times 1. Or 5 times 3. Okay? So, I'm going to do the wrong one first, just to show you. So, 15 times 1. Okay? So, that gives me 15x. This gives me 1x, which is equal to 16x. That is not my middle term. So I know that 15 and 1 are not my factors. So 3 and 5. Positive 3x, positive 5x, that equals 8x. That's my middle term. So my answer is x plus 3 times x plus 5. Now, are you asking how did I know what the signs were going to be? You can put your factors there, and then figure out the signs. Okay? I will tell you this. In order for my last terms to equal a positive number, when I multiply this number times that number, if it has to equal a positive number, I may not know what those signs are going to be, but I know that they're going to be the same. Because when you multiply two things, if it equals a positive, then they either both have to be positive or they both have to be negative. Right? So this second sign right here tells you whether your signs in here are going to be the same or different. If that last sign is positive, then both factors are going to have the same sign. They might either both be positive or both be negative. What do you think is going to determine what they're going to be? The what? The middle term. The middle term is going to tell you whether they're both going to be positive or both be negative. When you combine them, they have to equal the middle term, right? Okay. So let's do this one. What's my first terms have to be? B and B, right? Now, 32. My options are 32 times 1, 16 times 2. Now, y'all tell me, before I even do anything, are these signs here going to be the same or different? Different. Because that's a subtraction sign, so that means they're going to be different. Now, let's look ahead a minute. If they're going to be different, when I combine my inside and outside, am I going to be adding those numbers or subtracting them? Subtracting them, right? So, what am I going to do? What factors are 32? 8 times 4. So one's going to be 8 and one's going to be 4. So I'll put the factors down, then I put the signs. So when I multiply the inside, I'll get 8b, and the outside, I'll get 4b. Which one has to be negative? The 8. So that has to be a negative 8 and a positive 4. So let's check to see if we're right. So this gives me negative 8b. This gives me positive 4b. And when I combine those, I get negative 4b, which is my middle term. So I know that is correct. And it's okay if you put the signs backwards. When you check it, you'll get a positive 4b. And you'll be like, oh, okay, it's the right term, it's just the wrong sign, so reverse those signs. Now, these you could have done with the easy AC method, the short AC method, right? The next ones, we have a coefficient in front. These are the ones that get long with the AC method, okay? These are the ones I find to be easier with this method. So let's do this. Yes. All right. So my first terms only have one option. What is that? 2x and right. 2x and x. Now my last terms. I have to, factors are 12. 12 and 1, 6 and 2, 4 and 3. Let's just start trying. First of all, are my signs going to be the same or different? Same. And they're both going to be positive. I know that much. When I add them together, it has to equal a positive. So, let's try 6 and 2. So the inside gives me, the outside gives me 4x. 2x times 2 is 4x. And that together gives me 10x. Is that right? No. Now, before I switch my factors completely, you should try just reversing the ones that you have. So we tried 2 and 6. So the inside gives me 2x, the outside gives me 12x. Is that right? Nope. Okay, so done with 6 and 2. So now let's try 4 and 3. So let's try 4 and 3. So the inside gives me, the outside gives me 6x. Is that right? Nope. So now let's try 3 and 4. The inside gives me, the outside gives me, together they give me, done. Okay, we only have one option for my first terms. That's 3n and n, right? This tells me same sign. This tells me both negative. Both subtraction. Okay? So 3n and n. Now, for 8, we have 8 and 1 or 4 and 2? It has to be 4 and 2, because this gives me negative 4n. This gives me negative 6n, and when you combine them, you get negative 10n. So my middle term checks out, but when I multiply my first terms, 3n times n, I get positive 3n squared. So that term checks out. And my last terms, negative 4 times negative 2 is positive 8. So all 3 terms check out. If you had put different signs, if one was a plus and one was a minus, and this one, your middle term could check out, but not the last one. If you had, this was a minus and this was a plus, and if you had the 4 and the 2 reversed, then it would be negative 12 and positive 2, and that would give you negative 10, but your last term wouldn't be right. The sign would be wrong for your last term. If your signs are different, then it would look like this would be negative. Okay? All right, let's try another one. Try number 3. Same sign or different? Same, both? First term, we only have one option, 3x and x. 3x times x is 3x squared. My last term, 4 and 3. 4, positive 4 times positive 3 is positive 12. So this gives me 4x. This gives me 9x. Together, that gives me 13x. So it checks out. So it's 3x plus 4 times x plus 3. Okay, y'all work number 4. Okay, this means different signs. So one has to be plus and one has to be minus. So how do I get a negative 21? You could do negative 7 times positive 3, or positive 7 times negative 3. When I combine them, it has to equal a negative. So I want a larger number to be negative, right? So minus 7 plus 3. This gives me negative 7x. This gives me positive 3x. Together, that gives me negative 4x. Now, is it okay if I wrote my answer like this? Is that okay? Is it okay if it's like this instead of like this? Yes. When you're multiplying, they can be reversed. You still get the same answer. Okay? So that's all right. If your factors are reversed, it's fine. Any questions? Okay. The last part of this is, just like we did yesterday, factor then solve. These are just factoring. Now we're going to solve. Remember, to solve, first you factor it, then you set each factor equal to 0 and solve them individually. Okay, so we need to factor this first. In every step, you're going to bring down equals 0 equals 0. So when we factor this is going to be n and n. My signs are going to be different, right?
Yes.
So we only have one option, 7 and 1, right? 7 and 1. Which one's going to be negative? The 1, because when I combine them, I have to get a positive. So positive 7 minus 1. And when you check it, inside is 7n, outside is negative 1n. That gives you positive 6. Right? Now we take each factor and set it equal to 0. N plus 7 equals 0. N minus 1 equals 0. So subtract 7. So n equals negative 7. Add 1. N equals 1. So my two solutions are x-intercepts, or roots, are negative 7 and 1. How'd we do? All right, let's look at number 2. There's a red flag that goes off. There's a lot of big numbers, right? Can I shrink those numbers down? By what? Factoring out a 6. Okay? When you factor out, especially a constant, it's going to make all those numbers smaller and much easier to factor. So we're going to factor out a 6. That's my greatest common factor. So 18 divided by 6 is, so that's 3x squared plus 120 divided by 6 is 20. And 150 divided by 6 is 25. Now, since we're solving, if you factor out just a number, is it legal for at this point for me to divide both sides by 6? If I'm solving, I can divide both sides by the same thing, right? Yeah. And what happens if I divide both sides by 6? It gets rid of that 6 right there. That makes it easier, right? So that's what you do. Now, if you had factored out, let's say, a 6x, you cannot divide both sides by a variable to get rid of it. You can't get rid of a variable. All right? So if there was say we had factored out an x, that would stay on the outside. Okay? But you can divide both sides by the constant to get rid of it. And so what I'm basically doing is dividing both sides by 6. Now 0 divided by 6 is still just 0, right? So it didn't change the right-hand side. So we have 3x squared plus 20x plus 25 equals 0. Now, factor that, and then set each factor equal to 0. They're the same and both positive. Okay, so 3x and x, and then this should have been 5 and 5. So when you check it, you get positive 5x on the inside, positive 15x on the outside, that equals positive 20x. So we have 3x plus 5 equals 0, and then x plus 5 equals 0. So we bring the 5 over, it becomes negative 5. Divide by 3, so x equals negative 5/3. Bring the 5 over, it becomes negative 5. So my two solutions are negative 5 and negative 5/3. Okay? Now, number 3 works the same way, but we're going to skip over that so I can jump to one where I didn't have an example like it, but there's some in your homework like it, okay? So let's look at this one. Okay, so that if I didn't put the equal 0, it would just be a factor problem. But since I put the equal 0, it's a solve problem. Okay, factor then solve. Now, Let me let you get that copy. What's the first thing that I noticed? There is a greatest common factor, right? So, factor out your greatest common factor. What is that? 2. So I'm going to factor out a 2. That leaves me with b to the 4th minus 8b squared plus 7 equals 0. Now what? Divide both sides by 2 and get rid of it, right? So now I'm just left with b to the 4th minus 8b squared plus 7 equals 0. Now we can factor it. Now, just because my first term is not squared doesn't mean that it can't be factored. It can. Okay, in math 2, you only did quadratics. You only did to the 2nd power. But you can use this method for any of them, as long as it's to an even power. And so, the method doesn't change. First of all, same sign or different? Same. You look at the second one. This means they have to be the same, and they both have to be negative. Right? They both have to be negative. Now, same thing. What times what equals b to the 4th? B squared times b squared. That's how you get your middle term to be b squared. Do y'all see that? Okay. So b squared and b squared. I only have one option for 7. That's what? 7 and 1. Now, check it. When you multiply your inside, you get negative 7b squared. When you multiply your outside, you get negative 1b squared, which equals negative 8b squared. Okay? So it doesn't just have to be squared, it just needs to be even. All right? So now, how many solutions should I end up with? 4. Not necessarily all 4 real ones, but you should have 4. So we're going to take b squared minus 7 equals 0, and then b squared minus 1 equals 0. So, bring the 7 to the other side, it becomes what? Positive, so b squared equals positive 7. But if this was minus and you brought it, if this was plus and you brought it over and it became negative, when you take the square root, you just have imaginary answers, okay? So now it's b squared equals, so it's, you have to take the square root, so b equals plus or minus the square root of 7. So that's 2 answers, positive square root of 7, negative square root of 7. And then over here, you add 1 to both sides, so b squared equals positive 1. Then we take the square root, so b equals, what's the square root of 1? 1. So b equals plus or minus 1. So, my 4 answers are square root of 7, negative square root of 7. Now, you could just write plus or minus and just write it once. I'm just showing all 4 of them individually. And then 1 and negative 1. So those are all 4 of my x-intercepts, or my roots, or my zeros. They're called the zeros, because y is 0 at those points. Okay? Any questions? All right, let's do this third one. Take out your greatest common factor first. Now, at this point, we can't get rid of that x on the outside, but we can get rid of that 2. We can divide both sides by 2 and get rid of that 2. Okay? And that's okay. Notice it was to the third power. That means I can have 3 factors. X is my first factor. We're going to take this and break it apart into 2 other factors. So we'll have x times something times something. Okay? You can't lose this. Is that going to factor with the same, are they going to have the same signs or different? Same. And they're both going to be negative. Same sign, both negative. All right, 9x and x. And then 2 and 9. That's what works. That's what works. Inside gives you negative 2x. Outside gives you negative 81. And when you combine those, you get negative 83. So now we have 3 separate factors. Factors are things that are multiplied. So we have x equals 0, 9x minus 2 equals 0, and x minus 9 equals 0. So we have 3 solutions, which we should. This tells me I have 3 solutions. So here's the first one. So for the second one, bring that over, it becomes a positive 2. So 9x equals positive 2. Divide both sides by 9. X equals 2/9. Bring that over, x equals positive 9. So my 3 solutions are 0, 2/9, and 9. Okay, this is your homework. 12 problems, that's it.